Alright, this lesson is on 4.2, implicit differentiation. This lesson follows chain rule because it is trying to remind you that y is the dependent variable, and because y is embedded into your equation. So when you're taking the derivative, you are going to have to remember that it has a dependent variable embedded into the y. So y depends on x. So when you're taking the derivative, you have to make sure that y has a derivative that is still dependent on the independent variable. So the long story short, or the easiest way to remember this, is my steps here. You're going to treat the y variable like an x variable. It's just going to take the derivative as is, and then don't forget to tap on a y prime with it, because when you're taking the derivative itself, chain rule says, okay, you take the derivative and then itself has a derivative, so there's a y prime. Okay, so the best way to approach this, I would believe, is to make sure you have what I usually tell students to do is to have a red pen with them, because then when you're taking the derivative using implicit differentiation, you want to make sure you mark out all your y primes so you don't lose it. All right, so don't forget that however many y's you have to begin with, that's how many y primes should show up in the next step. All right, so let's see. And also, even though the directions here say dy dx, I personally like to write y prime just because it's a lot easier to write than to keep writing dy dx. So yeah, that's my suggestion. Okay, all right. So number one, you have y squared equals 1 minus 6x to the 2/3. So this is not a function, obviously, because y is squared. But because y is not alone by itself, which when you typically take the derivative, you just go y prime equals blah, 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 because your equation is already set as y. But in this case, it's not. So we have to do this thing called implicit differentiation. So what does that look like? So first thing you want to do is take the derivative of y squared. So if you treat it like an x variable, typically when it's x squared, you get 2x. So y squared, you get 2y. And because of chain rule, y has a derivative that's dependent on x, so you have a y prime here. Anytime you take the derivative of anything with a y, you need to tap on a y prime. Okay, that's kind of the rule right now. Okay, equal. All right, 1 is a constant, it goes away. The next thing you have negative 6, x to 2/3. So negative 6, that's your coefficient. Drop down the 2/3, x now to negative 1/3. Okay, so now let's clean up. You have 2y, so you'll have your y prime. Okay, now clean up the right hand side. You get negative 4 over x to 1/3. Yes, we typically like to write the fraction, the negative exponent, as a fraction. Okay. So then finally you want y prime by itself, because kind of like solving for y, same thing, you want y, you're solving for the derivative, so you want y prime by itself. So you want to divide by 2y on both sides. So if you divide by 2y or multiply 1 over 2y, you get negative 2 over x to 1/3 y. And that's it. So this is your final answer. And with implicit differentiation, you're going to get some really, really nasty expressions here. So just kind of be aware of that. Okay. All right. So that's kind of your first glance at implicit differentiation. You'll get more and more comfortable with it. Okay. All right. Next one, you have x squared plus sine of y equals y squared minus cosine of x. So if you look at this equation initially, you see there's a y on the left and a y on the right. So there's two y's. Therefore, when you are done taking the derivative in the first step, you should have two y primes that show up. Okay. All right. So we're going to take the derivative. X squared gives me 2x plus, okay, sine of anything. Well, sine, the derivative sign is cosine. So it's cosine of y. And don't forget, because now you took the derivative, you have a y prime there. Right? You took the derivative of the y, so you have a y prime. Okay. Equals, so that the right hand side, you have y squared. So the derivative of that is 2y, and once again, because we took the derivative of a y variable, you have y prime again. And then minus, all right, cosine x, the derivative of cosine x is negative sine x, so now plus sine x. Okay, so now you kind of have to follow the rule up there, because now you have more than one y prime. So if you follow the steps up here, it says collect the terms of y prime on one side of the equation, and then you are trying to factor it out. So I am going to, first of all, it might be easier to move this y prime to the front of the cosine y, just so you don't confuse it as an argument of the cosine. So I will look at this as y prime times cosine y, okay, minus the other y prime term there, y prime times 2y. So I move this one over to the left-hand side. Okay, so what stayed on the right? I have sine x, and I gotta move this 2x over, so minus 2x. Okay, now it's ready for the next step. Everything on the left-hand side has a y prime. Everything on the everything on the left-hand side has y prime. Everything on the right-hand side does not. So let's factor out the y prime on the left-hand side. So factor out the y prime. You get cosine of y minus 2y. And you still have sine of x minus 2x on the right-hand side. And then, so last but not least, to get y prime by itself, you will get sine of x minus 2x all over cosine of y minus 2y. And that is your y prime. Again, as I mentioned before, it gets a little bit more gross. It gets a little bit more complicated because you have more terms now and there's a lot of things that's embedded. So your final answer is going to be a little bit more difficult. Okay? All right. Next one, you have x minus y over x plus y equals x squared. So on the left-hand side, you got to use your quotient rule because you have a quotient, right? So let's do this. So the left side, low d high minus high d low. So low is x plus y, right? D high, so the derivative of the top, the derivative of x is 1 minus y. Well, the derivative of y is y prime. Okay, so low d high minus high d low. The derivative of the bottom is the derivative of x is 1 plus, and then the y gives me y prime all over low squared, right? Don't forget the right-hand side equals 2x. Okay. All right. So I can do a couple of things in this next step because there's a lot more terms here to work with. But bottom line, you want to do the same thing as before. You want y prime all on one side, and you want the ones without y prime on the other side. So my first step in this case would be to multiply the denominator to the right-hand side so that I have two terms, and also distribute out all the things on top. So make sure I use the distributive property to multiply everything out. Okay, so I'm gonna distribute this and make sure I get x minus x y prime. Okay, distribute the y, so y times 1 is y minus y prime. Okay, all right, be careful of the next distribution because you have a minus here, so again, kind of watch out for that. Okay, so I have x times 1, that's x, but don't forget the minus, so minus x times y prime, so minus x y prime, right? And then now I'll distribute this negative y, but don't forget there was a minus 2 in the front of it, so actually I'm distributing a positive y. That makes it easier. So plus y, and then y prime, beautiful. And on the right hand side, 2x times x plus y squared. I multiply that denominator over. Okay. All right, so a couple things should pop out at you. Negative y prime, y prime gone. X and minus x is gone, and I think that's it. That's all that goes away nicely, right? So that gives me negative 2x y prime, okay, and I have 2 y's there, so 2y equals 2x times x plus y squared. Okay, all right, so now if you notice that all the terms have a 2 as a coefficient, you can go ahead and divide that through. If you don't want to do that yet, that's not a big deal. I would just go ahead and subtract the 2y on both sides, so that the only thing left here on the left-hand side has the y prime, right? And then the right-hand side has 2x times x plus y squared minus 2y. All right, so don't forget, last thing, divide by negative 2x on both sides, so that you get a really nice answer of y prime equals, well, if you divide by negative 2x, you get negative, oopsies, sorry, you get negative x plus y squared plus y over x, right? And that's it. All right. So I am going to stop at this point because then the next piece we will go over on Thursday's class. Okay?